Hello, I'm going to go over lesson 112 now with you, which is about domain, range, and end behavior. To start off, I want to define what it means by a relation. So a relation is just any way that you can relate the variables x and y, or how you relate inputs and outputs. Okay, so in our case, we're just say simply a relation is a point x, y, an input and output. A function is a special type of relation where your x values do not repeat. Okay? So again, the x values do not repeat because the definition of a function is for each x, there was only one y, which that means x's don't repeat. So the domain or the inputs are going to be our x values of the relation, and our range or our outputs are going to be the y values of the relation. So let's kind of go through some of these things. So for number one, it says you're given the relation 2, 1, 3, 3, and 4, 5, and they want you to express it three different ways. So in our table, okay, so this could be your x and y, or you can also say these are your inputs and these are your outputs. Okay, so the first one, 2, 1, your input is 2, the output is 1. Then you have 3, 3, and then finally you have 4, 5. Now, if I do a mapping diagram, again, these are our inputs or our domain. These are our outputs or our range. So the first we were given was the 0.21. So you're going to say the 0.21. And you could honestly put these wherever you want. And I'll show you how to finish this off in a second. Now we got the 0.33. Again, you can put the 3 anywhere you want. You could put the 3 anywhere you want here. And then same with 4, 5. Now to finish off the mapping diagram, you just got to show what it maps onto. So a first one of 2, 1, our 2 maps onto the 1. So I've got to show that the 2 maps onto the 1. The 3 maps onto the 3. The 4 maps onto the 5. That's why you can put these in any order because you've got to show the arrow with how it maps onto. And finally, for our graph, we're given 3 points. So I graph the 0.21, I graph the 0.33, and I graph the 0.45. You do not connect them because you were given a set of points, so you just need to graph them as points. All right, so then for this one here, this asks for the domain. Okay, and if you remember the domain, those are your inputs or your x values. So again, you can think of them as your inputs or your x values. Now I gave you a set of points, so when you give me your domain, you need to give me a set. Okay, so what were all of my inputs? They were the 2, 3, and the 4. So 2, 3, and 4. Okay, now we go to the range. Okay, the range of a relation, okay, are the outputs, or they're the y values. So whichever way it helps you think. Now again, I gave you a set of points. So when you give me the range, you give me a set of values. So if we look at our range, the outputs or were the 1, 3, and 5. So 1, 3, and 5. All right, so now let's go through. So this one says, is the relation above a function explained? So when we look at this, if you remember, going back to a function, it says in a function, the x values do not repeat. So what I got to look at is my domain. Do any of these domain values repeat? When we did this, no, they do not. So it is a function. So you would say, yes, the relation is a function because the x values do not repeat. All right, so let's go to the next topic. So the next topic is the vertical line test. Okay, if you do not feel like writing out vertical line test all the time, you are more than welcome to write VLT. So it says the vertical line test states that to be a function, okay, the vertical line can touch the graph only once. So again, only once when you draw a vertical line. So for example 2, it says, are the following functions? So if I were to just to make an expression on this, I draw a vertical line. If I draw a vertical line, did I hit that only once? No, I did not. So this is not a function. Now here again, if I draw a vertical line, did I only hit it once? No, I did not. So that is not a function. And here, every single time I draw my vertical line, I only hit that parabola once. So yes, this would be a function. Okay, if you want to read through this next one, pause the video and try it. Great. So in the triad, it says your sister's arguing that this graph is a function since this graph is a function. Is she correct? Explain. So would you say that this is a function? Okay, since it's a graph, we would kind of do our visual inspection of the vertical line test. Draw my vertical line, hits more than once, so it is not a function. So you would say, no, my sister is not correct because that graph does not pass the vertical line test, so it is not a function. Okay, let's keep going on with this lesson. Okay, we're now going to talk about end behavior. So this right here says end behavior of a function. So please realize two important things there, end behavior, and also it has to be of a function. So if you don't have a function, you're not going to be talking about end behavior. And when we talk about end behavior, we're talking about when the ends increase or decrease without bound. So that's what it says. So it says as the x values either increase or decrease without bound. So I'm going to show you the 4 cases that we'll see. So on this side, we have the left end behavior. So I'll even write that in if I can find the pen I want. We're going to use this one. So over here, we're on the left. Okay, so on this side. So over here, it says as x. So over here, if you look, my x's, as they get more and more and more to the left, my x's are going more and more negative. They're headed towards negative infinity. So I would say as my x goes to negative infinity, and now I look at the left end, because again, these are called end behaviors. Okay, so if I look at the end over here, where's our end going? It's going up, it's going more and more positive. So I'd say my function is headed towards positive infinity. Okay, let's do the other left end behavior. So again, so I look at my x's because they come first. Our x's are going more and more negative. So I would say as my x approaches negative infinity, and now I look at this part. Where is this function headed, or part of the function? You're going to see that it's headed down. It's going more and more negative, so it's headed towards negative infinity. Okay, so now let's go to the right. Okay, so this over here is on the right side. Okay, so if I look over here for my x's, because again, it shows your x's first. Here, as my x's are going to the right, they're getting more and more and more positive. Okay, so I would say that my x's are headed towards positive infinity. Okay, now I'm going to look at my function. Over here, if you look at the top, okay, what's happening here? It's going more and more positive. So as my x's went positive, my function also went to positive infinity. Okay, so now let's finish this off. Okay, over here, for this one, what's happening over here on the right? My x's are headed to positive infinity. And when I look at my function itself, where is it headed? It's going down. So it's headed to negative infinity. So those are end behaviors. And again, it might be weird right now, but you're going to get plenty of practice. So we'll see how this goes. All right, so for our next example, they want us to find the domain, the range, and the end behaviors, if we can, of all of these relations. Okay, so let's check this out. Okay, let me just zoom in a little bit so it's easier for you to see. Okay, now the thing is, if any of your graphs come to the edge, you're going to assume it goes on forever. Okay, so I'm going to remind myself, what does it mean by domain? Domain are all my possible x values. So as I go along this x-axis, I look for a match. Now this graph goes on forever and ever. So every time I have an x, I have a match on my graph. So I'd be able to touch that line every time I go from an x to the graph. So my domain is all real numbers. The other way we're going to say it is from negative infinity to infinity. Okay, you could say all real numbers if you would like. Now let's do the same thing for the range. The range are my y values. So this time you're going from your lowest y to your highest y. So if I start at my lowest y, I'm always going to have a match on my graph. Every y can touch the graph. So again, it's going from negative infinity to infinity, or all real numbers. Okay. Now when it comes to end behavior, you're going to have 2 end behaviors. You're going to have left and you're going to have a right. But before I get to that, I got to check one thing. Is this a function? So if I look at this, every time I draw a vertical line, it passes a vertical line test, so it is a function. So I will have a possibility of end behavior. So now on the left, remember we start with the x's. So over here on the left, your x's go more and more negative. So I'd say as the x heads to negative infinity, and then I look at my function on the left. So down here on the left, at the very end, what is your function doing? It's going down, down, down. So I'd say my function is headed towards negative infinity. Okay, now let's go to the right-hand side. Over here on the right, where do your x's head? Your x's head more and more positive. So I'd say as my x's are going positive or positive infinity, and now I come to the very end on the right, what is my function doing? It's headed up, up. So I would say that my function is headed to positive infinity. Let's try part B. Okay, so part B, my domain. Again, those are my possible x's. Well, if I come over here, I don't have any x matches at all on my graph. The first time I have an x is at -6. Then if I match, I keep having matches on my graph. Match, 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 and all of a sudden I don't anymore. So just from here. So from -6 to 6. So from -6 to 6, I have matches. Since this is a value right here, this will be a bracket. This is a value right here, it's also a bracket. Another way you could write that is that my x's are in between -6 and 6. So whichever you prefer. I tend to be an interval person, so that's why I think of it first. Now your range are your y values. So if I come down here, I'm not touching the function at all when I'm looking at my y's. First time I touch my function is at this y, which is 0. And then I can touch my function, touch, touch, touch every time until here, because once I get above that, I'm not anymore. So my lowest y was 0, my highest was 6. So I'd say from 0 to 6, there was a value here at 0, and there was a value here at 6. So, or I can say my y's were between 0 and 6. Okay. Now we go to end behavior. Again, we have a left and a right. But first thing I got to check, is it even a function? Every time I draw a line, yes, it is a function. So far it's a possibility. Now again, end behavior is that it goes without bound. So if I come over here onto the left, is this going on forever? No, it's not. So there's no left end behavior. Now I go the same thing on the right. Is this going on forever? No, it's not. So there's no right end behavior either. All right, we got 2 more to try. So domain, we set our x's. So come over here, nothing, nothing, until right here. So my first domain value is 0, all the way until I get to this 4. And again, you can write it as an inequality if you would like. Now the range, my lowest y value, I can see is -4. My highest y value is 4. Okay, now end behavior, I'm not even going to look at it, because if I were to check, this is not even a function. So I do not have to check if there's any end behavior. And the very last one. Again, when a graph goes to the edge, assume it goes on forever. Okay. Now my domain, my x values. For every x I go to, I notice that I can head down or up to the function. So my domain is all real. Okay. So from negative infinity to infinity of x's. Or again, you can write the all real symbol. Now for my range, my y values. When I start down here, I realize I'm not touching the graph at all. So the first y value I come to is this 4. And then it just keeps going up every time from there. So I'm going to say my lowest value was that -4, and then it kept going up to positive infinity. Or I can say all my y's are greater than or equal to -4. Okay, now my end behavior, I see that this is a function because it passes a vertical line test, so I do left and right. Now on the left, does it go on forever? Yes, it does. So I'll have left end behavior. So as my x's go negative, so as the x's head negative, and now I look at the very end. So here's the very end, and you talk about your left end behavior. You would say your function is going to positive because it's going up. Now let's go to the right end. On the right end, your x's are going more positive. So as your x's go positive, and now we look at the right end for a function. You can see over here that the function is going up. So you'd say that the function's headed to positive infinity. All right, that's lesson 1.1.2. Let us know if you have any questions.